All right, so let's now look at another problem for doing optimization. So as an example, this problem is specifically good for students who are on track to go for the business major or business career right here. And so, but in the end, those students, any students or viewer who are not on track for business major, you can view this video lesson here as an additional understanding to expand your understanding of how you can apply maximum and minimum value problems into optimization. Okay, so let's spend some time reading the wording of our problem here. So the owner of a small fruit orchard decide to sell gift baskets during the holidays to make some extra cash. So the cost per basket for making X baskets is so this is C bar here. Notice. So if you are a student in business, in a formal business major, you should be familiar with the quite standard C bar notation right here. So it means this is the average cost function. So capital C is always for cost, but the C bar here is for average cost. And the way how the function is named here is really consistent with the goal here. It's a cost per basket. So that means this is the average cost right there. So that's what C bar is. But in the end, anyone viewing the video or even including the business major students, you don't need to worry about how this average cost function is obtained. In other words, we have this average cost function given. So C bar of X equals 0.01 x squared minus x plus 180. And so now in the wording of the question, part A. And so be ready that we will be having another question coming out of this given information. But in question A, how many baskets should they sell? Should the fruit orchard here sell to keep the cost per, we want the cost per basket at a minimum. Okay, so along the way as I read, I start picking out information so that we will have an idea ahead of time of what to do right here. All right, so that's briefly how we read the information given in a problem. So let's get back on my board here and we're going to get started into doing the problem. So as usual, as the experience after we've learned in the general lecture of how to carry through an optimization problem, which is the apply problem for finding maximum and minimum value problem, then again our first goal here of the problem, our first step in doing any of these is to find out for ourselves what is our objective, and then from there we're going to be able to identify for ourselves the objective function. And so our objective here, okay, and as the objective, let me one more time swing back to the wording of the problem. But it says right here that we want to keep the cost per basket. So this is namely the C bar that we are given right there. Okay, but I'll come back and highlight that later. But we want to keep the cost per basket at a minimum. Okay, so right here with this information that was already highlighted, I now have for ourselves an objective. So we want to minimize. We want to minimize the cost per basket. Okay. And so according to the wording description right here, then the number of baskets is represented by, so X here is the number of baskets. Okay. And so one more time, I'm swinging back into the wording on my computer screen right here. And so we already had for ourselves. So right here, this is our function, our C bar function, which is the cost per the average cost function being given as a 0.01 x squared minus x plus 180. So what's good about having this function given for us now is that, so even though we have already identified our objective here is to minimize the cost per basket, but we already had our objective function simply given for us in this problem. So it saves us one step finding the objective function. So we don't have to do that here in this particular example. Other problem we have to, but in this problem we don't. So C bar is already given for us. So now I'm just simply going to write it down. So it's always a good habit to write down, even if you don't have to spend any effort at all to find it. We're still going to have to write it down to keep it clear for us. That's where our objective function is. So the objective here is to minimize the cost per basket, but mainly we work on this objective function. So now the function itself is at 0.01 x squared minus x plus 180. Okay, so my board is getting a little busy, but this part right here is our objective function. So now let me go ahead and maybe put that in a box right here for viewers who can, and for any viewers to have a better view of that. But so this is now our objective function. We have now identified that. Okay, and so now with this objective function, it's quite and the good thing about it, I can never guarantee that in other problems or in other examples we will have an objective function as ready as this one. And ready, I mean it's already in terms of one variable. This function is a function of one variable, which is directly ready for us to do any kind of later work. So in that way, the further importance, I mean the further impact is that we won't even have to spend our time, our efforts to look for the constraints at all, because this function has already been in its most simplest form that's closest to our reach. So anyone at the beginning calculus level can tackle down with this problem easily. Okay, so now we have our objective function. We don't need to find any constraints for this. So in that way, let's go ahead and get started, and that really saves me a lot of board space right here. So C bar prime, and see, this is the objective function, and that's the one we want to minimize. So we just get straight into C bar prime of x, and x here is the quantity, the number of baskets that can be sold. Well, the usual power rule that we have learned is going to give us 0.02 x minus 1. So that's our derivative on the average cost function. So our objective function in this case here is indeed an average cost function instead of the usual cost function, which admittedly business students are more familiar with the total cost function, the usual cost function, rather than the average cost. But once in a while, once we've had that as a function, it will work just like any other function. Okay. So our C bar here, C bar prime is 0.02 x minus 1. So now again, here we really are starting to get back to just the standard steps of how to find a maximum or minimum value problem of a function. So the next step now is to set our C bar prime of x to equal 0. So this is, we purposely set our C bar prime equal 0. And so from that point on, we're going to produce for ourselves an equation 0.02x minus 1 is equated to 0. And so now that's going to give me, I'm going to add 1 from both sides here. That's just some quick algebra. And so 0.02x equals 1. And then in the next step here, from 0.02x equals 1, I am simply going to divide both sides by 0.02. Okay, and x will come out equal 50. Okay, so let's take a quick pause right here. So 50 here, recall that the meaning of the x is still here on the board. X is the quantity. So again, for business students, sometimes the example we will use a q as the variable for quantity, but here it use x. Be ready for be flexible with any of the way how these variables are being named right there. So it could be x, it could be q, it could be in n or whatever. So here x is our quantity. It's a number of baskets. So it means here is that at this is the critical value at this number of baskets being sold, then we're going to have either a maximum or a minimum average cost. So that means the next step is going to decide whether this critical is going to give us a maximum or a minimum, or even neither. Because as we have learned, again, in our general lecture for finding a maximum or minimum value problem, when we ended up at a critical value, it didn't tell us anything yet. We have to test further. And so I am going to apply the second derivative test in this problem, even though we've learned that there are two different ways we can either using the first derivative test or second derivative test. But since, again, based on my experience, I can see that this function is simple enough. This function is simple enough because it's just a standard polynomial, and specifically it's a quadratic. And so I can just quickly find for myself the second derivative. So C bar double prime of x is simply from our first derivative. Now it's going to give me just a constant 0.2, and this time it's a positive 0.2. And so this is what I meant earlier by, using the second derivative test is going to be a little easier. In this case right here, it's simpler because it saves me from building sign charts. That was done from in the first derivative test. And here, directly the second derivative of our C bar here is already a constant value. So that means when we're substituting in 50 for our C bar double prime, so C bar double prime 50 is that same constant 0.02, which is already a value positive. So that now means C bar of x. So back to C bar here. This is just a test. We test to find out whether our function is reaching to a maximum or a minimum at this critical value. But now once we've ran into that final test result right here, then this is the conclusion. C bar as our main objective function is minimized. See, that's if anyone is being a little surprised about how this inequality leads to this conclusion, then I highly recommend that go back and review my earlier video lecture regarding how we can use a second derivative test to decide whether a critical value will produce a maximum or a minimum. So C bar is minimized, or how about a better way of saying that? C bar, okay, is at has its minimum. That's a better way of saying that. C bar of x has its minimum at x equals 50. So now we made our conclusion. When we can sell 50 baskets, we made the minimum C bar average cost, or cost per basket right here. Okay, and so this is just a conclusion. But so now let's swing back to the wording of the problem right here. The question is asking, how many baskets should the company, should the fruit orchard, should the owners of the small fruit orchard sell to keep the cost per basket at a minimum? And so all of a sudden, looking back at this question right here, it is so obvious that we have already found for ourselves the answer. And the answer is here. This is our answer. So at selling 50 baskets, then we can minimize, we can achieve our C bar function to be at its minimum. Okay, and so this is our answer. It just happened to be earlier a conclusion, an interpretation of what this result means, but now that is also our answer. Okay, and so same question, but now let's look at part B right here. So part B now of our problem, of our same example here, is looking at, according to the wording, what will be the total cost. And so now this total cost here, I have to be clear, it's difference with the C bar. So what will be the total cost to the owners for selling the number of baskets in part A? Okay, the number of baskets in part A. And so now on my board, back in part A, we have found that when we're selling if we can sell 50 baskets, then we can minimize, we can make our cost, the average cost or cost per basket at the smallest, as the least cost per basket. But this is the average cost. Okay, so, but the question here wants to want to find out what will be the total cost. So that's why I highlighted it here. So now I have to remind, and this is the reason why I'm saying that this particular example is good for students who are in business major, because any of you who are in business major is familiar with these functions right here. But I also had earlier video lectures that specifically introduced about cost function and average cost, and made some difference between, and clearly made some difference between two. But total cost is always, so now just total cost is the C, no bar. Okay, total cost is always, well, how about, let me put it this way. Average cost function is always the total cost function as a cost function in terms of quantity, and divide by the number of quantity. So this is the fundamental relationship between average cost and total cost. So this one right here is the total cost. So just the traditional C is total cost. And this relationship that I'm putting in the box right here is the relationship between average cost and total cost. So in that case, right here, in that way, algebraically, this is just completely the algebra at this point. The total cost, because we already knew our average cost. So once we've had average cost and coming over to total cost, all we do is just simply multiplying this x right here in the denominator here to both sides of our equality here. So that means total cost now is the quantity multiplied with C bar times x. Okay, so now it's a little extra experience for any of us who have known already this relationship, but now this is something else we can do with that. Okay, so what's good about this in our particular problem? So now when we look back at that result we have found in part A, and now let me erase all this work that we have done already. So now x equals 50. Okay, is the number of baskets that minimize our average cost. And so that means we want to find out what is the total cost when we're selling 50 of these. What is the total cost when we're selling 50 of these? And the wording is right here again. What will be the total cost to the owners for selling the number of baskets in part A? So the number of basket in part A is 50. And now if we substitute 50 into C of 50, that's how we're going to find the total cost as a function of quantity again. And again, this is for students viewing this video who are in business major. You will be having a little more advantage because you have been learning about these functions a lot more fluent than other students outside of the business field right here. But in the end, we really didn't have the formal total cost function. But the only important information we knew was, and let me remind again, C of x is x times C bar of x. That is the only thing we knew so far. But we can make use of that immediately. So C of 50 is the same as 50, the quantity, multiplied with C bar at 50. All right, so 50 times C bar 50, that will give us the total cost at x equals 50. Okay, and so now that means we're looking at 50 multiply, and now C at 50 just basically means we're going to go back to our original average cost function that I had it written here, and substitute 50 into every single value. Okay, And so now that means I'm going to open a pair of brackets here, and we're looking at 0.01 times 50 squared minus 50 for the x and plus 180. Okay, and at this point I am going to quickly step away to do a calculation, and I should be back shortly. All right, so I have come to finding that the total cost here will be, so C at 50 at after my final calculation equals $7,750. Okay, and this is final amount, so let's put $sign in that. Okay, $7,750. So that's how we found our answer. And so what I really like about this problem that we just did is that it's a very creative applied problem in business major, because you see, we started out mainly handling the average cost function, and then from that cost function we effectively come up with the total cost. So earlier we were handling the average cost function, but then once we come up with the average cost function and the quantity that minimize our average cost function, we are able to come up with this total cost that's happening, that total cost that's happening at this number of baskets being sold right there. So it's one problem that leads to other consequences. So part A was a problem where we mainly handle the minimization of this C bar function, of this average cost function. But then in part B is more like a creative work that we can push it further and see what else we can do with that.